Hello everyone, this is Akshay and welcome to our channel of our GFG POTD streak of day 99. So we are almost closing to our day 100. So it's just a matter of today or tomorrow's date. So if you are new to this channel and if you like my content, please like, share and subscribe so that we can learn, grow and maintain our streak together. So today's question name is Scrambled String. It's a hard category question with points 8. So let's read the question and try to figure out what maybe we can do to solve this question. So given the two strings string S1 and S2 of equal length, the task is to determine if S2 is a scrambled form of S1. What is a scrambled form? Scrambled string is given the string str, we can represent it as binary tree, okay, by partitioning it to non-empty substrings respectively. Okay, so let's say for this coder, they have chosen CO as the first children and DER as the first children. It doesn't mean that the first children, this first branch should be the CO. They said that any non-empty string, so they could have taken just C in one branch and the ODR as the second child. Okay, so this is one of the below is one possible representation that was I was thinking here. So this is one of the possible representation. So to scramble the string, we may choose non-leaf node and swap its two children. Okay, so there is the functionality that if you choose any non-leaf node and you can swap the children. Suppose we choose the node CO. Okay, I chosen this node CO and swap its two children. So if I swap CO, its two children, that will be the O will come here and the C will come here, right? So it will be OCDER. So that's what it has given, OCDER, right? So it has done nothing but it has swapped the childrens of CO, and then in a level you can, if you found a string, then it will be OCDER. Similarly, if you continue to swap the nodes DER, so if we swap DER also, then it will be first it was OC and then it would be OCERD, right? OCERD. Okay. Okay. Okay, so there is note given here that scrambled string is not the same as anagram. Okay, so it's actually not the same as anagram because anagram is nothing but any two string which has the same number of characters in it, written in any order. But here we have to consider all the possibilities of dividing a particular string into two branches where each branch should be a non-empty string. We will discuss that. So print yes if S2 is scrambled from S1 of S1, else print no. Okay, so for coder, the string one is coder and we need to check that if it is scrambled string of S2, that is OCDER. So output is yes. It is saying that OCDR is a scrambled form of coder because you can see that OCDR can be split into two child, that first child as OC and the second as DER, and OC as ONC. So as you can see that OCDR can represent a binary by partitioning to 296. We just have to swap OC to get the coder. Okay. Yes, you can swap these two characters, that is OC, this is OC, right? It could be as C and O, and then you can combine with this children and CODER, you will get the answer, right? Okay, so one thing, and if you do not think in respect of binary trials, let's see what's the time complexity. So it is n square and the string length is 31. So if string length is 31, that means we can do this solution in recursion also. And I think we need to think of a recursion solution because whenever you are given this complexity, this constraint as this some very small number, that means that you can apply exponential solution, and then maybe you have to optimize with some memorization and tabulation, and then you can go with this O of n square. So this is the thing, you must know how to read this thing also if you're not getting hints of this question. So I was not able to get any hint. Okay, so one thing I can say in regards to index, what can I say in regards to indexes? Let me explain it to you. So this question is actually a good question. So it actually took me also a lot of time to solve this question. So I've come with a way to explain it to you guys. So maybe bear with me for some 10 to 12 minutes for this dry run. So what I'm saying here is that for a particular index I, let's say I'm saying this, right? So for a particular index I, so if index I is here, then the index I will be here. I can say that if I compare the S1 of 0 to I, and if I compare the S2 of 0 to I, and S1 of the remaining thing. If I have taken 0 to I, then what's left? Because you need to branch it to, right? So if I've taken 0 to I, and I is actually exclusive. So if I say that s dot substring 0 to I, that means I'm actually considering the characters from 0 to I minus 1, right? I minus 1, right? So let me use some different color. So I can say from I to n, from I to n, the remaining characters will be s2 from I to n, and here the remaining characters will be also from I to n, right? So what I have to see, that if this thing, I'm just talking about for a particular index I, and I have specifically chosen this index because I want to show you one observation here. So if you write 0 to I, it will be CO, right? This will be CO because it is taken, the substring function works till I minus 1 index. So it will be CO, and similarly it will be CO here. The rest of the thing, that is DER, and that I have represented with I to N, that is I will write DER here and DER here. So I can say that if I compare such thing for a particular index where my actually answer, here in this case my answer is happening, right? If I able to compare this thing and this thing, then I can say that we have achieved our answer. I will say return true, return true. So this was the first case. Just try to bear with me. I'll explain you. This is the second case. What should be the second case? That maybe there are multiple swappings happening, right? Swapping is happening. So now maybe the string is reversed. The first string is as it is, and the second string is reversed as, let's say, DER and CO, or vice versa. Maybe this would have also been reversed, right? So let's just reverse one thing here. So if it is reversed, and then I'm again talking with respect to a particular index I, right? So if I'm dividing it COD and ER, this S1 string, this is S1 string, and this is S2 string, then I can write that S1 is belonging to the index of 0 to I, right? And that means what? CO. Similarly, for the rest of the thing, for the rest, it is actually S1, right? This is actually S1. So if I have divided COD in 1 and ER as the second, so it will be what, from I to N? So it will be ER, right? Actually, DER. So CO is the one and DER is the next one. I'm dividing it this for a particular index I. What's the observation here? And for the particular index I, since I is here at this third character, so it must be here at third character, because I'm talking for a particular I which stands for same in both the cases. So again I will say that S1 of 0 to what? I, right? So this is reversed, right? So I need to compare. So initially what I was doing one partition in the beginning and one partition in the beginning in the second string, and I was comparing the first partition with the first partition. But second case is what? Reverse. So and I don't know it's reversed or not, right? I cannot check. I need to code it, right? So I have to see that first partition is now maybe equals to the second partition. So let me draw it with different color. Maybe if that string is reversed, then the first partition will be equal to the second partition, right? So for this thing, I need to compare with what? This is I. So I need to compare what is this index. If this is I, then then the immediate starting index will be n minus I, and till n I have to see. So I will just write n minus I till n, right? And similarly, now the second thing is, this was the for the second partition here, and the next query I'm writing is for the first partition, right? So I will say that 0 to n minus I, right? Right? Okay. So I need to compare this thing. So if this comes as CO and this also comes as CO and this comes as DER. So if you see that these two are the only cases where are the division of a string into two binary, uh, let's say, branches, into two binary strings where each branch should be a non-empty, then these are only the particular two cases where I need to compare with respect to an index I, right? Because if this is CO and suppose this is OC, this was OC, but suppose this was also as CO, but that we can swap it any number of times, right? We can swap it, right? So it didn't matter if this is CO or OC. CO is always equals to OC because we can swap it. So okay. So what can I do? So I when I started the dry run, I said for a particular index I. And I showed you in such a manner that I was always giving an answer in these all two cases, right? But there will be a situation that I will not give an answer. Suppose if I have placed the I as somewhere here, right, then you would not get an answer. It will be at COD and then ER, and you can see that this is OCD. The alphabets itself are not matching, then how can you swap it and get to an answer? So that means we don't know for which particular I will get an answer, right? So what I need to do, so my step one will be, I need to check for each and every index. So for I equals to 1 to I less than n I plus plus, right? I need to do that. And I will store this thing, let me use a different color. I will store this thing as string A, and this as string B. A and B will be compared, then C and D will be compared. Similarly, E and F will be compared for each and every I. Similarly, G and H will be compared for each and every I. And as soon as I get that A is equals to B and then C is equals to D, that means that we have got an answer and you just return true, right? If both belongs to true, right? Okay. So I hope you are still here with me. Okay, so let me write this thing here and then we will discuss about the base cases. We will go stepwise. I don't want you guys to be confused. Okay, so let me just make a function. Since the initial main function is given as static, so I need to make the another function as also static. And line number 38 is not a main function, sorry for that. It's just a function, so it's static. Then we need to make a function static again, so that it can refer to it, so that it can call it. So string s1, let's say, and string s2, right? So I need to run a loop for each and every index. I don't know where my answer exists, so I will say that I less than n and I plus plus. And also the string length should be equal, right? The string length should be equal. If the string length is itself not equal, then we cannot do something, right? And it's written that mm, it is equal in each and every case, right? Let me equal length, it is mentioned, so I do not need to add an if statement to check if the lengths are equal. Okay, so what I said that I will make string A, right? And I will substitute the value of s1, the substring value, from what, 0 to I, and s2 from 0 to I, and then I to n and I to n. So let me do that. So substring s1 dot substring from 0 to I, right? Similarly, let me copy this line and I will paste it 3 more times. Okay, so this is B, this is C, and this is D. And A is compared with B with the S2, that is 0 to I, and this is S1 from what? The remaining string is I to N, so it will be I to N, and this will be I to N. So A and C are coming from the same branch, right? This A and C, as you can see, both are pointing to S1, right? So this is from the two binary branches of non-empty subsets from the same string, and B and D are from the S2, right? So this was the first four, and this is our first case, right? The second case, the second case is that maybe the strings are the non-empty subset strings are placed in reverse order, right? I don't know that, so maybe in reverse order. So I need to check for both of the cases, right? So I will again make 4 more strings with the second cases I showed you in the dry run. So I will make this D, E, F, G, and H, right? And let me see what were the values. So 0 to I, n minus I to n, and I to n. So 0 to I to n. Let me just write that. So 0 to I and I to n. Those are written there. So what's next? So it was n minus I to n and 0 to n minus I. So let me replace that. So it was n minus I to n, and it was 0 to n minus I. Because this is the case that maybe it has been in reverse order, and that's why I will be comparing the first partition of the S1 with the second partition of the S2, right? This is the second partition of the S2. Okay, what I will do now, I hope you're clear till this point. This was the main intuition. So I will just say that if my function of a comma b returns true, right? And function, because still my I have compared just the first partition with the first partition of S2. I still need to compare the second partition of S1 with the second partition of S2. So I will write function of c comma d. If both returns true, that means that I have received an answer. So in that case, I will say return true, right? Similarly, for this case, I will say that a function of e comma f, right? And why and because we have just compared one partition from S1 with this with the one partition of S2. Still, the other partition of S1 is left to compare with the second partition of the S2. So I will write function of g comma h. If both say that yes, our condition satisfies, and we will discuss about the condition, which are our conditions we are talking about, then return true. So what are the conditions now? The conditions will be that we are comparing two strings, right? The strings should be equal, that it may be that it is equal. In this case, CO, and it was OC, right? Okay, so it was OC. I have written OC. It was OC. But as I said, that it could have been CO also, right? It's just the matter of swapping we could have done as said in the scrambling, as mentioned in the question with the help of scrambling, right? But in this case, this is OC. So it didn't matter. So I will just, or if I just show you case where there must be some case where of equals to. Ah, yeah, you can see here, this is CO and this is CO, right? So there will be a case that there will be an exact match. So if there is an exact match, what I'm writing now, I'm writing the base cases. If there is an exact match, you don't have to nothing, you have to just return true, right? Return true. Okay. And okay. So these are all the first things, right? And now, since this is recursion, and what are we doing that for each and every, I have explained you how memorization works. So let me tell you. So why memorization we need to apply here? Because memorization is something like, let's say you need to find the Fibonacci of 7. Then what you do, you call for Fibonacci of 6, you call for Fibonacci of 5. Then 6 call for f of 5 and it calls for f of 4, right? And f of 5 calls for f of 3, it calls for f of 2. And similarly 4 calls for f of 3, f of 2, and then it goes till f of 2 and then f of 1, right? And f of 2 calls for f of 1 and then f of 0. So memorization says in a very crisp term that whenever you are making a recursive call, store it somewhere in DP array or in any data structures that aligns with your storage data type. So here in the Fibonacci, we can just use int a DP array. So if you see that there are overlapping subproblems, I calculated for f of 5 while doing all the recursion from f of 3 to 2 then to 1. So I don't want to do the same work here. I know if this thing return x, then this thing will also return x. So why not just store this f of 5 and do this thing? So that's the concept of memorization. So in this our question, how the memorization is helpful, we are doing a recursion, that's for sure. So whenever we are comparing strings, then there may be a chance that we at some point of time, let me write it for you. At some point of time, there will be chances, of course there will be chances, that we are comparing the same strings. We are uh, I will just write comp the same strings. So how to overcome that case? So I need that there is S1 and I know that there is one S2, right? And I know that if I compare it again with the another thing, then S1 and S1 plus concatenation of S2 again come in some of our other use case. So what I will do, I will maintain a map where the first thing will be string and the another will be boolean, or let's say you can take int also. So boolean true will just say that this string is already present in a map, right? And we have marked it as true. So if you come across this string again, you just mark it true, right? You just mark it true. So we will make a a global hash map, right? So let me make a global hash map. Hash map, it will be string comma boolean. So it will be boolean, and let me name it as map, right? Okay, so it should also be static because every function is here in static reference. So it will be string comma boolean, and boolean b is capital. Okay, so we have made an hash map, so let's declare it also. So map is equals to, okay, map is equals to new hash map, right? That's it. And I need to return this function. So I will just say return function of s1 comma s2, right? That is it. And if it is equal, then also you put it in the map, because for next time I don't want to recur the recursive branches. I just will see that if it is contained in map, then I will directly say return true. So I can just say that if at any point s1 is equals to s2, that we are comparing for this function a, b, c, and d, then put it in the map. So I will just say map dot put, concatenate the strings, that is s1 comma s2, and mark it as true, right? That we have this string here also. So this was the thing, then the string was equal, right? So I can also say that if string is not equal, but it is in the map, if it is in the map, so what I will say that string s1 plus s2, if it is in the map, then just check it that if it is true or not. So if it is true, that if it is containing, then just return if it is true or false. I don't it doesn't matter. I just need the answer, right? For every recursive call I made once, and I will utilize it for the next steps. That's the whole concept of memorization, right? So I will say the map of get s1 plus s2, right? Using map here may be a little confusing to you, but you stick to the basics as I explained you for the Fibonacci, right? It's nothing but as if we are using an int dp array, right, for storing an integer. But here our use case was to store a string as well as a true or false value for it, right? So that's why I used hash map. So it's stick to the basics and you will be uh, like getting the code how I'm writing it. So that is it. Okay, so first case we have written and the second case. So if it is true, then I need to put it also, right? I need to put it for the future references. So I will just say that map dot put s1 plus s2 comma true, right? Similarly for the second case, that if we are solving that recursion part, then store it. So I will again put it. That is it. And after the end of the for loop, it's that not the case, then what I need to do, I need to put the things at s1 plus s2. If we do not fall in these two cases, that means that we were not having this scrambling string present. So I will just say that s1 plus s2 is false, and I will say that return false. Return false. The final answer will be false, right? So that is it, I guess. So let's just submit that. Let's just compile the code, and before submitting it, I will show you a dry run also. So cannot find the symbol. Okay, so I have always used the capital letters and I have declared the string as small. So let me do it as capital, and let's compile and run again, and we'll see for ourselves. Okay, so I have not declared n. What is n here? So n is nothing but the s1 dot length, right? So I will just say that if me, I will say that int n is equals to nothing but s1 or s2 dot length, because both have the same length, right? So let's compile and run again. Okay, so there's an error of index out of bounds. Let me rectify it very quickly. Okay, I got one error in this line number 74, as it is showing that I have to use n minus I, and I have mistakenly typed in as 1 n minus 1. So let's compile and run again. Okay, so my output and his output is coming different. So wait guys, let me rectify these errors. What are they? And then I'll explain it to you. Okay, I found the one crucial error here. It should be s1 s2 s1 s2, and again s1 s2 s1 and s2, because we are making two partition, not three partition for each and every string, right? So let's compile and run again for the last time. I hope this time it will pass. So it passes, right? But before submitting the code, let me talk about this time complexity, and let me show you a dry run also for our very small cases. Whenever the recursion is involved, you must not dry run it for a larger cases. You must not just dry it for the small cases, and you have this recursive leap of faith. You have to leave it that it will run for the larger cases also. So let me tell you that how this code is working. Okay, let me clear. So how is this happening is if I just write on the exact code I written it for you is for we have this let's say a COD and then DCO. So as you can see, if I just make a dry run that if it returns a yes or no, then what can I do? I can make COD to DCO or not. Hmm? I can make it or not. Yes, I can make it. How I can make it? So let's say I am what I'm doing that in COD I am moving this character CO here and then rest of this DO. And for any non-leaf node, right? This is a non-leaf node. We can swap as children. So if I swap the children, it will be COD and it will be D and it will be CO. And this swapping is just the definition of scrambling. That what I'm doing. I'm doing scrambling here. Do not mention my handwriting. It's scrambling written here. So DCU, as you can see, that COD can be converted to DCU, and the answer is yes. If you just dry run it also using the compiler, you will get yes an answer. So let us see that how our code is giving answer for this thing, right? Sometimes you need to write code first in case of recursion by following an intuitive logic, and then you need to see that if that code is actually working it for you or not. So I'm explaining just for you guys so that you can have a clear understanding. So you must try run it for the small cases. So for I equals to 1, I am calculating A, B, C, D. I am calculating E, F, G, H. And I am calculating S1 of 0 to 1. 0 to I it was, right? And then it will be S2 of what? 0 to 1. And it was S1 of 1 to N. And it was S2 of 1 to N. And if I just mention this thing that this is 0, 1, 2, it is 0, 1, 2. And 0 to 1 it will be C, it will be D, it will be OD, and it will be CO, right? E will be nothing but what, S1 of 0 to 1 according to our code, and S2 of 3 minus 1 to 3, and it will be S1. Because S2 it will be S1 of 1 to 3, it will be S2 of 0 to 2. And if I just write the strings, that is C, this is O, this is OD, and this is DC. As you can see that none of the characters are equal, right? None of the characters are equal. And how are we comparing? We were comparing with this A to B. A to B, you can see that this is not equal. Let me give a line. This is not equal, and not equal, right? So we cannot put anything in our map. This hits the actually base case. It runs for, if I just show you the recursive call, then it calls for COD and the string was DCO. What it did, it calls for I equals to 1, and where it goes off function of, first of all, it goes to function of A to B, and A is nothing but E and F, and it hits the base cases that this is not equal. So it did not return anything. It does not contain a hash map also. The two if it did not do. So what it does, so it compares the C and D, so it compares G and H, right? Sorry, not G and H. The actual string was OD and CO, so it is not equal again, so it moves forward and it sees it will go for CO. It is not equal again, it will bypass all the two if base cases. It will see for OD and DC, it will again bypass the two if statement. So the last iteration for I equals to 2 will be finding A, B, C, D, and will be finding E, F, G, and H, right? So it will be nothing but S1 of 0 to 2, it will be nothing but S2 of 0 to 2, it will be S1 of 2 to 3, it will be S2 of 2 to 3, right? So the strings will be CO, DC, D, and O, right? For this case, it will be S1 of 0 to 2, it will be S2 of 3 minus 2 to 3, right? You verify the values from our code, right? I'm not explaining that here. So it will be again S1 and S2 of, I've already explained, so that's why I'm writing fast here. So the strings will be CO, CO, D, and D. And as you can see, we need to match these things. These things again does not matches, matches. So matches and matches. So here the something change will be there. So for I equals to 1, we ran it. For I equals to 2, we have to run it. And it will see that the function of the first string, that is CO and DC, not equal. So it will again bypass the 2 if statement. It will compare DC and O not equal, bypass the 2 if statement. But here, as you can see, CO and CO, right? CO. So these strings are equal. These strings are equal. And here the magic happens. So in the map, it goes as CO dot true, right? Again, the another function of D and D, right? So it goes as D comma D as true. And if both the functions were true in the code, what we were doing, that we were also putting s1 plus s2, and for this s1 and s2 is this one. So I will say that cod and dco is true, right? The third entry will be cod and dco comma true. So this was the smallest base case I ran it for you. If you take some more characters here and here, then you will see that the map, the the entries that map now have, will be used in the future references. So that was the main logic here, right? And what's the time complexity of the time complexity will be that we are running a for loop, right? That takes O of n, and inside the for loop we are visiting each and every character, right? Each and every character, in the sense that if you are making the partition like this, then we visit these characters, right? So at the worst, we are visiting each and every characters in the partitioning of into two non-empty sets, right? So it will be the n square, and the space complexity will be, let me think about that. So let me explain you in detail that how the space time complexity was O of n square. The first was O of n into for loop, and as you can see that there was a string COD, and what you did, you divided into CO or OD, right? And then you again, since this was the more than one character, so divided again into O to D. So as you can see that we are continuously dividing into two branches as soon as, until and unless we hit the one character. So what I'm doing for n, I goes to n minus 2, then I go to n minus 3, and finally I go to n. So that means that we are doing an n level work, right? And we are just visiting it once and storing it. So that means n for the for loop and n for the division that we are making. But what is the space complexity? So the space complexity will be, if I look at this my try run where I made the recursion relation. If you see that the string length is 3, then we made an almost 1, 2, 3, 4, 5, 6, 7, 8 recursive call. So if you just try to make some numerical numbers logic that 2 belongs to it, it is almost equals to n square, right? And we are also using hash map to store all the strings, so that also contributing as O of n. But the recursive stack is itself taking the n square comparison, so it will be O of n square. So I hope you were able to understand this video. It was a bit complex, not complex, the hard question is sometimes lengthy and you need to think, and whenever special case comes, the recursion thing, so you need to think for a very minute test case, and then you need to write the code, as well as you need to try run it for it holds true or not, right? So I think I have not submitted the code till yet, so let me submit it. Let me submit it. So great, as you can see, the problem is successfully solved. So tomorrow will be our day 100. So let's rock our day 100 streak. And few last thing, that's my DSL repository. You can start and fork together with the source code. You can connect to me on the LinkedIn, as well as this public Instagram channel made for just for you guys, for any doubts and guidance you may have. And let's connect tomorrow for the day 100 streak, and we'll have some post celebration about also. And till then, tab tak ke liye, bye bye, take care, keep learning, keep growing, and just take care.